Thanks for staying with me on this series. Looks like there's going to be 6 episodes or chapters where I go from the blank to making these finished ITTP bodies. This 5th video is going to be about the Tormach 4th axis and setting up the part on the 4th axis. Please stay through to the end, and I'll talk at the end about the business a little bit more, about the intellectual property of the business. Now we're going to do some 4th axis work where we're going to do some engraving, spot some holes for the adjusting screws, and then drill those holes. So this is where we're at the moment with the part, and that's what we're going to end up with, hopefully. So we're going to check that the 4th axis is concentric where the mandrel is mounted. You can see there I'm just checking that that is mounted correctly. It can be adjusted on its flange in this case. We're going to check that the 4th axis is clamped on the table correctly. And we've got it aligned in those 2 directions. I won't go into great detail on setting up the 4th axis because in my playlist, again, I've got a subject, a whole series of videos, a playlist of 4th axis, and there's one called 4th axis set up and run where I go into setting up the 4th axis and running it in great detail. So this is just going to be more of an overview specifically for this job. Now we're going to set our tool length offsets. You might have seen the other video on the other mill doing this. So that surface across bridging those 3 surfaces is our reference 0. So we're just going to probe that reference surface. And don't forget to plug the probe in. And probe Z, just check that it is plugged in. Yes, probe Z, set work origin. So we've set that as our origin. Now we can take the probe out and set our tool lengths using that little mechanical tool length setter. So we're going to enter in tool 22 for the engraving and spotting tool and come down to that reference surface and touch on the button, set tool length. Now we're going to do the same for the drill, which is tool number 30. Enter that in and come down to the same Z surface and set tool length again there. So we've just set the 2 tool lengths into the tool table. Okay, now I'm going to set the work offset, or if you like, the spindle center line to the work center line. So we're going to use the Hallmark probe to set the probe. So I'm just going to use a square, come around to the back, come in contact with the back diameter, and check there's no little bits of dirt on there, and the square's sitting down. I'll slow down the probing speed rate to give me time to position it. I'll show you what I mean by that. So here we are, we're going to go to Y find center. So it's quite slow at the moment. It's found one side. Come around to the other side. I'm just slowing it down temporarily just for this job. Found the other side there. And I can speed it back up again. But while the camera's rolling, I'll keep going. We'll set the Z, probe Z set work origin. It's not bad having the probe running quite slow in a way. gives you a bit more time. Set the X, probe X, set work origin. And there we've set up the X, Y and Z. So while the camera's rolling, let's just quickly add in there how you would adjust the probe speed. So probe set up there on the probe page, and we just come over to here. So I've got the rapid probe feed at only 500 and the rough probe feed only at 200 millimeters a minute. You can edit that to suit the particular job you're doing. So again, we're setting up the engraving cutter, and you don't have much clearance with these D-bit type engraving cutters, but it's really important to get a finger indicator and check that you do have rotational clearance. So there the dial indicator is not in contact with the cutting edge. Coming around there, it's coming in contact now. That's the maximum position there, 1/100th of a millimeter on the cutting edge. Carrying on round, it's backing off, so that's good, we've got clearance. We've got about 5/100th clearance, and I'll continue to rotate it to make sure there's no run out, to make sure the heel is not dragging in the cut, and then it's dropping off there. So that's good. We've got about 2 thou clearance on the cutting edge. That obviously limits the feed rate, but these type of cutters cut really well and give a nice finish. It's just important to set it up correctly, because with the TTS and all the different concentricity errors, it's very easy to have that set so that it rubs and burrs and doesn't give a nice clean cut. So I'll keep putting that cutter back in that rotational orientation, so that it always repeats that position. Well, you probably heard in the background while I'm setting up this 4th axis part of the job, I'm also running the other 1100. Soon I'll have them both running at the same time. Just thought I'd mention these covers. This rear splash cover is really useful because it stops chips from mostly from getting down over the back there onto those accordion or bellow covers over the y-axis. And if you get too much chips or swarf in there, it can bunch up and start to damage those covers, and very soon you'll have micro tears or holes in the covers, and the chips and grit can get down, and it's directly above where the Y ball screw is, and you really don't want grit and chips dropping onto the Y ball screw, or in the cutting oil dripping through onto the Y ball screw, because that's going to wear that very expensive precision part of your machine out. So prevention is better than cure. I really like this idea of a splash guard there to keep the chips away from that area, and another cover here on the front to keep the chips off this area. It's quite simple to do, and it can really protect those relatively delicate bellow or accordion covers over the top of your slideways. Have a look in the playlist for maintenance videos on that specific subject. I'm just going to test this cutter a little bit above the work before I actually put my first part in and run the job. You know, it's right at the end of the day, my brain's feeling a bit tired. There's a lot of things I could have wrong. I could have it rotationally misaligned in some way, or one of the work offsets wrong. So I'm just going to run the cycle a little bit above the work. We'll turn off the coolant. I'm just moving the maximum velocity slider a little bit up. It should stop just above the work. Now we can go 100%. And you can see I'm a few millimeters above the work. Just checking I haven't done anything stupid before I cut the first part. So I came in really slow, and now I'm just running it to make sure that I've got the program set as per the last time I did this run. Just a little safety move, only takes a few minutes and it avoids a horrible crash. I've just slowed the RPM right down. I could have even turned it off just to keep it quiet. Some of you might be interested in how do you produce that code for the 4th axis engraving. I think I've got a video called Wrapped 4th Axis Engraving. Wrapped 4th Axis Engraving, something like that. I did it quite a few years ago, but should have some useful information in there. So it's also a way of refreshing your memory and your mind as to what you're actually doing. You know, it's spatially quite complicated, and you could easily ruin your first part or even have a crash. I want to have a look to see where the spotting of those adjustment screw holes goes, just to remind me where the program ends. I see there's a little bit more engraving in there, and now we're going to come down and rotate to this position, and we're going to spot drill that. That's on 65 degrees on the A axis, the 4th axis. We're going to come around now, that's on 185 degrees. It's just 3 adjusting screws on these probes. I would have liked to have 4, but the Tormach protocol is to have 3 on their own probe and on the software, and so I sort of stuck with that. I would have liked 4, it'll be slightly quicker to adjust. Anyway, it ends on 305 degrees on the A axis. Well, that's interesting. So I've got to think about all that now when I set up the first part to have it in the right rotational position and so on. So mandrels are a really common way to hold parts in a 4th axis. Obviously they're set up concentric. Using a cap screw is a good idea if it's sort of a below the surface situation. You can see there I've got little location pins so that the part is referenced in a rotational position, and this is a bit awkward with holding the camera in one hand, but you can see there the advantage of a cap screw is that it's below the surface and out the way, and if I had a nut on the end of a thread, then I'd need to use some sort of a socket if there was room. So that's locking it up against a flange. This face is a flange, and a cap screw is also often better than a nut because it's quicker to tap a mandrel than it is to screw cut a male thread. So that's how I'm holding this body onto the mandrel. I pulled my super spacer apart when I first got it a few years ago, and I was a bit disappointed to see the quality of the assembly. The design looked quite good, quite rugged and solid, but the assembly was poor. There was burrs and dirt inside, and it really needed cleaning and deburring. So if you have one of these, it's a good idea to do that. And also, it doesn't have large reservoirs for the oil lubrication system, and so it's a really good idea to give it a good shot of the correct oil in the little oiler buttons there, there, there and there. From memory, there's those 4 main ones, because there's only very small little pools of oil inside. Set the A axis on a rotational move, you know, GOA 1000, so it'll run for a while, and then inject oil into those 4 places at the start of a job. Wait a minute, did you just say you dismantled your super spacer? Yes, I did it, and I dismantled one of my 1100s as well. Really, you've got to do this type of work for the love of it. There just isn't enough profit in it. If you're based in New Zealand and you're manufacturing a product for export that is indirectly competing with Chinese manufacturing, you're not going to get rich. you've got to do it because you love it. You know, if you want to be profit orientated, then you'd need to become a lawyer or a real estate agent or something. But I do it mainly for the love of it. Well, that's the first part out, and it looks really nice. Really pleased with that. So it's running quite slow. I've got a slow feed rate to give a nice surface finish, but that's okay because it's running automatically. The other machine's running automatically, and so I can be doing something else. So that's 3 jobs happening at once. So I'm not too much worried about cycle time. I've got another series of videos where I built my own stands and enclosures. This seems to be a series of reminders about my playlists of videos. So if you're interested in building your own stand or enclosure, I built this really compact one which is only 55 inches wide. If you've got a small space in your workshop, or 1.4 meters, that's smaller than a 770 enclosure, and it's an 1100. It's got a system of a sliding door that is also swinging out, and there's no top bar there, so you've got full access when the doors are open. This monitor stand just swings out the way as well. So if you're interested in building your own enclosure at some stage, there's a series of videos there in the playlist. I don't know whether the latest model Tormachs have a problem with the drainage system blocking up with chips and those little outlets there, but the earlier ones certainly do. So I found if you make these little mesh baskets and just fold them up just out of that soft aluminium mesh, is it? Or is it soft stainless steel? Anyway, you know, you can buy that stuff from a garden supply store, and it just cut it with snips or heavy scissors. That really increases the length of time that it will run for before it blocks up. I wanted to talk briefly now about the business and myself, if you're interested in those subjects. Some of you might be thinking, well, you know, aren't you disclosing a lot of the IP, a lot of the intellectual property here? I mean, what's to stop somebody copying it after they've watched these videos? And I was really concerned about that in the early days as well, and I was very secretive about some of the internal intellectual property, some of the internal design. But I've come to realize, thinking about it over the years, that the real intellectual property is not so much that. I mean, anybody can buy a probe and dismantle it and reverse engineer it and start to produce it in substance of what it is, but not in detail. The real IP is some of the finer points, the choices of the materials and the final dimensions, and you can't get that easily even by dismantling one and carefully looking at it. I found initially when I developed the probe it was very difficult to get it to run reliably long term. You know, I could get it to run for a few weeks, but then I'd start to get little issues. And these were the same sort of issues that other owners of probes were having. The same issues that I had with the probe that I had bought. And I really wanted it to be long-term reliable. And I had to keep tweaking different material choices until I finally got a combination of material choices and dimensional tweaks. And I finally got that combination that allowed it to be really reliable long-term. Well, that's the real intellectual property of the product, and that's easy enough to keep secret. So the other thing is that the website and the reputation of the company is also the value of the business. So I am quite happy about releasing this sort of IP now. Thanks for watching this video series, guys. I really appreciate it. I hope to continue to produce videos long term. I really enjoy that side of things as well. Cheers!